Welcome dear friends, this is Mathdoctor and let's begin with the new concept of probability, that is Total Probability Theorem. It's Mathdoctor. So in the condition probability, we have to find out the anything else by considering some event. So in this lecture, we are going to find out the probability of finding any event from any which we have given for any condition that is event. So we have given event number one, event number two. These whole are condition. We have to find out the total probabilities from each and every condition. So then we are going to look at the base theorem, and that's the prerequisite for proceeding to the further. So you must watch it carefully. So what the total probability theorem wants to tell us. So for example, when we first out our condition probability theorem, so in the in an example of choosing out, this is uh, bag number one, that's bag number two, and there are some three black balls, three black balls and one white ball and two white balls and actually eight black balls. So what we are going to find, we have to find anything else. In the condition probability, we restrict ourselves to only one bag. So first of all, we applied the condition, that is we have to just take our total only to bag number one. So what's happened? So we are just restricted ourselves to bag number one. Then we are going to find out the probability of A. A represents the event. A represents any event, that is A represents the probability of finding A. It represents it is black ball. So B represents it is a white ball. So if there is a, so I have to find the probability such that A is also, but the black ball is from the bag number one. So what's the probability of that? So this is the very easy concept which we have done in the previous lecture, the condition probability. So what happened when we so let's reverse it and just put it here and B1. So what's the probability of first of all A? Then we will find about the probability of B1. So because we know that A is already happened, A is happened. So A is nothing but A is a black ball which we have taken from the bag. We don't know which bag we have chosen. So we have to find that bag. So we have to find that bag. So we are just considering the total number of events. So how many bags are there? So we are adding up the probability of that. So first of all, we are looking at the ball is drawn from bag number one. So both events should be happen. So both probability for finding its event, we are using our multiple theorem. So it's nothing but, so here we can write in two ways. We know that must watch my previous lecture of multiple theorem. So it becomes prerequisite for proceeding again to the another lecture also, next lecture also, and this one out. And we can also write what's the probability of A at that said that B2 is already contained. So B2 we have to find we have to draw black ball from the, so A represent the black ball from the bag number two. So this is how where we use our mind. So for considering what to write, so we know that probability of finding A, we cannot write it in such a way that, so we cannot write in such a way. So this should be written in a way that probability of finding, because we know that probability of finding black one is easy instead of finding probability of A. So that is what we are going to look at. So we don't want to write in this way, because it is the reverse process which we will discuss in the further topic, that is Bayes theorem. So here we're going to use probability of finding A such that it draws from B1. So that's the so that's how we can write probability of finding A such that B1 is already taken. So this is the conditional probability. By using it, we can find the probability of drawing black ball which is noted by A. And also we know that we are using multiple theorem for finding it. For first of all, we are jumping into what's the probability of black one, and what's the probability of such that we have taken the black first bag, and then we're going to find out the A event, which is the probability of drawing a black ball. So that's the main idea about what we can use in this lecture. So for finding out total probability theorem, again we're going to write it in whole. We're going to write here also, because we cannot write in this way probability of B2 and A. So this is totally wrong. So we must have to write in this way probability, because in the early classes we have discussed we can write in both the ways. So that's how first of all we split. So this splitting creates a very important role. So what's the probability of finding A from either E1, because we have to find the reverse base of conditional probability. So we are considering each and every event, either it's from E1, either it's from E2. So it must be in any bag. So it must be in, so E2 represents the event, so it's a bag actually. So which bag? So we have to find in the next lecture we are going to find out the reverse process of the condition theorem. So if we have drawn the black ball, then what's the probability it's from first, or it's either from bag number 2. So that's how we use our total probability theorem. So in order to know that what's the total number of outcomes, so we can also draw from black, white, and there may be another bags which we have given to us. So we are restricting our question to only this. So we have given one black and one bag and another bag, that is B2. So we are going to write probability of finding A. So what's the probability of A? This is the total probability theorem just tells us it must be we just taken this out of here, that is because we write A, again we are going to write this into this way. So let's do that. Probability of finding B1 into probability of finding A such that B1 is already done, plus probability of find it must be in probability of B2. So it's just as easy as we do daily calculations, common calculations in our daily life. So it must be as easy as to do costings or so anything else. So this is our what total probability theorem tells us. So it just tells us what's the probability of A. So we know that for finding our black ball we have to go through one channel, but that channel we have to decide first of all. We don't have any condition A, so that A represents the black ball which we have drawn. So A does not have any condition. So A must also have a condition. So this is what Bayes theorem tells us. So Bayes theorem just tells us, which we have discussed in the next class. So for having to find out the reverse, because we reverse our because the condition we have taken, we have reversed it, because we have to find out the condition that from which ball we have which bag we have taken. We have to find out the probability that it's a black ball or anything else which it is given here in the reverse process. So both are reversed. So then we have to find out the probability. Check out, first of all, we are going to check out, it's in a blackboard. First of all, we're going to check at the uh, bag number 1. Then we're going to choose the bag number 2, such that because we have choose the bag number 1, then we applied condition for finding A. Then again we choosing bag number 2, and then again we are. So that's the total number of possibilities for finding of the our black ball. So but we have to find any one probability, which we will discuss in the base theorem. Let's look at another example of, suppose we have just given that person is has undertaken a construction of job, any the probabilities of that there are 0.65% probability that the work will be done. So how now there is some point to be considered as, because so it represents the maybe it represents the strike to be done, and we know that this represents that the strike cannot be happened. So this is given to our question. So this we can find by intuition, by subtracting it from the 1, because if it is strike to be done, and it should be not strike should be done. So that's the percentage of not strike to be done at the time of construction. So it is given to us either there is 0.80%. It's not a percent, it's just 0.80. So it's 80% actually represented the percentage that the construction job will be done on time if there is no strike. So if there is no strike, then this is the probability of doing our work properly, doing our construction work properly. So, and this is the probability that construction work will be done if there is strike. So this is the probability. So this is not our, this may or may not be 1, because if strike is happened, then there is high chances of doing our work properly, and this cannot be confused with that. So that if strike is happened, so sometimes we must have confused. So this is the number of probability. It represents actually probability, so it's not a percentage. So that's why we don't use percentage bar. So we are going to choose, this is the probability if there is no strike. So what happened? So what's the total probability? This is the total probability theorem tells us. So what's the probability of construction to be done? So we know that for construction to be done, so for finding the construction, so this is the probability of this we have given that if strike is no strike, if there is no strike, so which represented by S, and it is represented by S naught. So it represented by construction by S, and represented by construction to be done if strike is not happened. So we have given this condition, strike is not happened is 0.35. If strike is happened with this is 0.80. So by using this formula, we also know that what's the probability of doing strike. what's the probability of strike not to be done? That's 0.35, 0.65. So we can now, just using our formula, what's the probability that the construction can be done? So it must be in a both a way that, so if the strike is happened, then what's the probability? And by adding another factor, that if there is no strike, then what's the probability of that? So we can write in a normal way that both strike is done and construction is done. What's the probability of that? And also construction is not done, but strike is not happened. So what's the probability of a whole? That's how we just add the total probability of theorem as the final thing which we have must practice by taking an example. So that's the main idea, because we have given here S, so we can not write it as C. So now here we can write C, so that S is already happened, and S dash plus C, so that S dash is already happened. So this is how we can find our, by putting the values. So 0.65 into 0.65 into this is 0.8 plus 0.35 into 0.35. So that's how we can find out our answer. So it's nothing but 0.52 plus 0.105. So that's what the idea about we can use. This is the probability of 0.625 is the probability that we can look at. So that's the another example we have taken out. So this is how we have done with the total probability theorem. I hope you like my video. See you in the next video. So have a good day. Have a nice day. Thank you.